Today we continue our discussion on functional programming, and today we work on something else. Last time we worked on the recursion, okay? And I talk about recursion is the basics for you to do functional programming. If you want to do any functional programming, you need to know how you call function by function. So recursion is a must, okay? If you really want to explore the functional programming. Today, we are going to look at more topic on the recursion and tree, okay? So this is the lecture 8, what we actually focus on this one. Will be more focused on the recursion and tree, okay? Before we get started, any questions so far? About homework or anything else? Okay, if not, we get started for going through this chapter, okay? So I'm saying this one still actually following the chapter 7, okay, lecture 7, and basically still on this the different recursion and function of programming, but we are going to touch more topic now, a little bit more complicated things, okay? So how to make functional programming on parallel processor and this different recursion and recursion over tree, okay? So first thing is that the beauty of the functional programming, okay? Why functional programming is easier. As you can see, if you do object-oriented programming, you have to design heavyweight objects, okay, classes, and then a lot of functions. So functional programming is actually more direct, and then actually saving code, and then also there's no side effect. So the most common programming language currently used for AI is Python, R, Scala, Go. Okay, among others, okay, they will be the addition of Julia developed by the MIT. Okay. And then in the ancient day, like 1960, 70, they are Lisp and Haskell. So I personally learned functional programming while I was in college and learned Lisp. Lisp is the first AI language that I learned, okay? Let's back to 1980 something, okay? and then these are something that you can implement the machine learning algorithm for AI, okay? But nowadays Python supported and even JavaScript supported, okay? So today I'm going to change gear for the example from Python to JavaScript, okay? To show you that whatever you can do with Python, you can also do in JavaScript, okay? And then you know that JavaScript is a website web programming language, so you can bring the AI to the web, okay? So functional programming feature, before we see functional programming in the machine learning, let's look at some of its characteristics, okay? So functional programming primarily is immutable. A variable is declared and used in the program. The variable never get changed, but it may be used to generate new value, but the data, we try not to update the data on the variable by itself. It's called immutability. And then referential transparent. This means that an expression or computation always result the same result. So no surprise. So this is called referentially transparent programming language, okay? Anyway, these are just some features. And lazy evaluation, that means that you evaluate the value only when you need the result. So that's also dynamic typing, dynamic scoping, okay, those kind of issues. Is primarily used for functional programming, especially Python and JavaScript, okay? And then parallel processing, since there's no state change due to the immutable variable, the function in the functional programming can work in parallel. So there is no data dependency, because you update your data, you will have data dependency, and with the data dependency, you cannot go parallel. For example, you have A equals C plus B, right? your A plus G, you go to H. So these two statements, because you have the data dependency, your A's result need to, this instruction 2 need to wait for instruction 1 to finish. So there's a data dependency. So these two instructions cannot be parallel. Okay, that's called forward data dependency. Another one is you actually A plus C equals B, and then your A equals let's assume that it's E plus F. This one is reverse dependency. Even though you don't wait for the result for A, okay, but actually your instruction 1 still cannot be parallel with instruction 2 because you need to hold a value for instruction 1. If this guy updated, then your instruction 1 cannot do. So this cannot be in parallel. Okay, this is reverse dependency. So because of the immutability on the data, your functional programming will tend to be what? To be parallel programming possible. And this is one advantage that when you use a parallel processor, you can, if you have a good compiler and you map your functional programming to your processor, it will be much, much faster, okay? So, for example, Python's main processing engine is using the media CUDA, okay, plus Python, okay. So Python accelerator usually is CUDA Python, okay, and using a media GPU, okay. So we are not trying to teach you this, okay, but just telling you that where Python parallel functional programming goes, okay. Okay, anyway, that's Python, and let's look at other feature. Other feature, because these are new to you. So for some of you, maybe these are new. So don't use your Java knowledge or C++ knowledge to understand it, okay? Functional programming, you have higher order functions. So higher order function, take one or more function as argument. So when you pass function as argument, or use a argument, use function as a return value, we call it higher order function, okay? So basically you have a function F, but you take some other function G as input, or generate another new function called H. This we call it a higher order function, okay? And then higher order function are useful for refactoring call. Generate new call, okay, generate new call, or reduce repetition, okay, whatever. These are higher order functions. We'll see the beauty of higher order function later, okay? And what kind of programming is good for AI? Okay, machine learning is a subdomain of AI, okay, in which deal with concept of making prediction on data, okay? Okay, so basically the term AI is that we use artificial intelligence. We mimic the function of the natural intelligence, say neural network, okay, Faraday logic, something that existing that we use an artificial way to do it. That's called artificial intelligence, okay. Machine learning is a learning model. It's one kind of AI. It's not a totally everything that AI have. Machine learning just means that you do use update system, adaptive system to update your knowledge every time. So you keep your knowledge base updated and you use a large volume of data. That's called machine learning, okay? Data science is the science of handling data. So data science may include machine learning, may include AI, okay? So that's what the relationship is. So what is good about AI programming? Once the data is collected and prepared, it is time to build your machine learning model. And the model matters a lot. So basically, that's for AI researcher. And right now, it's the top paid job, okay? So AI researcher's job is to build a model, right? Machine learning engineer is not to build a model, it's use the model to actually build a learning process and build up the database, okay, the model they have. Okay, so that's the job of AWS machine learning engineer. And then data engineer is preparing the data. So it's like a little bit like a technician in this food chain. Okay, so data scientist is for the analysis of data. Data engineer is responsible for preparing the data for the models. So it's a lower paid job in terms of the AI industry. Okay. Anyway, these are just some brief introduction for AI job and programming. Okay, so OOP with mutable object, which object is better suited for high level production software and not very useful in AI. So that's why functional programming is better for AI, but OOP remain for high level graphic user interface type of programming. Okay, so here we do see the paradigm shift from the graphics part. We use window programming, website programming, it's object-oriented programming. And then going into AI, we go into functional programming, okay? So now it's actually different era now. So as AI heavily on math language like Python and R, okay, so it's actually these R and Python are widely used in AI industry. But when you really need to have acceleration, I would say still C++ is the highest performance AI language right now so far. So C++ 14, 17, 20, 23, they kind of adding the functional programming more now. Okay. Okay. Anyway, so that's actually AI, whatever. Let's call a more consistent the advantage for functional programming. Okay, and then simple approach, faster computation, whatever. Okay, and functional programming is fault tolerant and important for AI. Okay, whatever. So powerful programming language for doing machine learning. You can have JavaScript, you can have Python, Kotlin, okay, Swift, C++. These are language for machine learning right now. Okay. Let's look at program structure for functional programming. So functional programming means that you have a function, you can take data or vector input, you can take function input, you can generate vector output or function output. Okay, this is functional programming. And then there are structure for functional programming such as higher order function that you actually take function as input. Okay, you can have decorator. That's actually Python will have the functional decorator. We'll talk about it. They are querying. Okay, they are functional chaining. These are 4 different program structure in functional programming. Okay, and function higher order function, you take function and input to generate output and function. Okay, this is the concept. So this we look at it before. Okay, the name for it. Take vector in, function out as a function factory. Function in, function out is function operator. It's multiplication of your function. Okay. Okay, first one, let's look at querying. Querying is not Indian curry. Okay, it's different. It's querying. It's partial argument application. So when you apply partial argument on your function, we call it querying. Okay. So let's assume that actually we have a function, and then they return a function called b function, and then take a parameter b and return a plus b. And we can run this function that's called querying S3 and then parentheses with 4. Okay, let's look at how this works. First one, you pass the parameter 3 over here. You return the function. This function, let's assume this function called g function. Okay, this g function has 1 parameter. So this add function actually would generate a g function. So this one really is calling g of 4. G of 4, your b is 4, and your S3 is has a g function that actually would S3 plus your b, right? So basically H3 generate one function. That function is called G function. Now take one parameter B, and that's 4. And the return value is 3 plus 4. You will actually end up with 7. This is curry. Okay, one thing is that you can do this. You can do F3 and you assign to a function called H3. This is valid. Last time we do this, and then you do H3 with 4 later, and you generate 7. This is okay. So last time we teach you this maker of function. This one now. This one you directly make the function and then you directly use it. Okay, let's try this one on JavaScript. Okay, let's try this one on JavaScript instead of using Python now. Okay, so first thing is that let me bring up the same good tool, Visual Studio Code. Same tool for Python, we can also use it for JavaScript. Okay. And then second one, I'm going to use some of the graphic user interface that I have on the internet that I developed before for some kids. Okay, so this one is the CodePen. CodePen is the fast developer environment. Okay. So what I want to have is the GUI setting. Okay, so it will help us more. Okay, so that's actually okay. I'm bringing up this one. So let me create a new directory. Okay, so this one, let me go to here. This one is no longer Python, so let me use a new directory. Create a new one called JS JavaScript developer. Okay, that's my habit. So here, let's go for lecture 8. I usually organize in this way. Same course, I have PY dev for Python development, and then JavaScript dev, if there's a JavaScript. Okay, so lecture 8. So first one, let's actually try this one. Let's call it add.html. Okay, so this one we created add.html. So let's get started for the code HTML. Okay, closing with HTML, and we do have header section. We do have body section. Okay, so this one, and the header section doesn't have the title. Okay, let's call it JavaScript 1 addition for currying. Okay, that's the title of my HTML page. Okay, now I'm going to copy something from here. So I'm going to copy CSS section. Let's set up a style. Okay, that's what I want here. So here's style. Okay, and then put in the style of my page for body and panel. Okay, so tap. Okay, move it in. So I have one body and one panel setting. Now I need to, inside the body, I need to put some data here, some web structure here. So I'm going to copy this one. There's a button called click, and there's a panel called message panel. Okay, that's the two things that I have. One button, one message panel. Okay, now I'm going to create something called script. So this JavaScript is over here. Okay, so whatever I have for JavaScript will be here. So now I'm going to copy the JavaScript session from my CodePen. So that's my main function. Okay, so I'm going to copy the whole thing here. Okay, that's my JavaScript. So this JavaScript actually has a main function. So whenever you start this program, just like your Java program, you get started with main function. Okay, you get started with main function, and then panel set to be empty. Okay, and we are going to write something to the panel. Okay, and this year we actually don't want it. Okay, so let's delete it. Okay, and then these are inputs and the prompt, and okay, well, this portion that's actually comment them out for the time being. Okay. Okay, so let's actually try this page now before we do any programming. Okay, before we do any meaningful programming. So let's try this one. So to run it, you just go to the directory. Let's preparation of my first JavaScript program. Okay, that's just run. So this one, after running, you do have such environment. When I hit run, my messaging panel taking no effect. Okay, let's try this. Let's actually HTML equals here. When I click main, let me see something wrong. Okay, something is wrong here. Okay, I'm missing the curly brace. Okay, that's why the function have warning. Okay, let me say one more time. So here, let me actually refresh it. So here I hit wrong, the data being clean. Okay, the messaging panel being clean. Okay, this part we are fine now. We set up the environment and it's working. Okay, so basically what happened is that whenever I hit run, you run this main function. Okay, so now let's actually define the function. So here we do have a function definition. This function called add. Okay, so add the B. Okay, I'm sorry, add A. Okay, and then this function will return a function. This one is anonymous function. It just has no name. Okay, and this one will return actually A plus B. Okay, so this is actually the add function that we talked about. Okay, now this one is actually create a variable. Okay, x equals to add 3. Okay, and 4. Okay, so we get a result, and then we do this. We do panel that inner HTML. Okay, equals to plus equal. Okay, let's use plus equal. Don't use equal. Plus equal means that you add into it. Okay. Okay, so here we do have actually x equals, okay, plus x plus BR is change line mark. Okay, change the line. Okay, so we do get a result. Let's save, and let's double click on it and run. X equals 7. Any questions so far? So this is currying. Let's try something else. Okay, let's try something else. So let's try, this is the first one. So let's do variable y equals add 3, 4, 5, 6, 7, 8, 9. This is curry. Okay, and then let's copy this over. Let's put y. Okay, and this garbage I can now delete. I don't need anymore. Let me push the whole code inside the function main. One tab. Okay. So let's save, and let's run my add function one more time. Run. Oh, something wrong. Okay. I didn't save. I didn't save. Okay, let's try one more time. Okay. No, why still not there? Okay. Let me see. Okay. In this case, let's try to debug it. So use inspect. Okay. And now let's see. Let's go to console. Okay. Whatever is not a function. Okay. Type a uncall error. So there's an error. Okay. So let's see here. Actually, it doesn't. Okay. I'm going to update this one later. Okay. So let's try a different one. Let's try 3. Let's try 2 and 5. Okay. My setup, maybe this A function is not for currying, not strong enough. Okay. Let's try later. Okay. So Y also 7. Okay. So this one is one user at 2, 5. Okay. So let's try another one. You can create an adder 10 equals at 10. Okay. And then you create variable E equals adder 10. And then 5. Okay. So let's look at E now. E should be 15. So this one is still a functional generator, but it actually do not provide chaining. Okay. I'll work on another version that provide chaining later. Okay. So this one save. Let's look at DG. Okay. Wrong. Oh, something wrong. Let me
Header 10.
add 10.
Down, next one down. There you go.
Okay. Wrong name. Okay, sorry. Okay, the bad part is that the JavaScript usually the debugging system is not good. So you have to use the inspect sometime to check the value. Okay, check if they are error messages. So we are using this as a debugging environment for JavaScript. Okay, but anyway, this one show you a basic function of function factory, how to generate function. Okay, but this one doesn't give you the chaining effect. Okay, doesn't. So that's actually, let me post the code to the group, okay? So you can look at this add.html, 44 line, put it in the chat, okay? This one called add.html. Okay, but it's a beginning part of a higher order function. We do have such things that JavaScript will work just like your Java, okay? So now next one is a function. You do x plus y, okay, this is a plus function, but you can actually generate a currying function so that you have partial input from another function. So here you put here this one to be partial of the function. Okay, this is called currying. Okay, so basically you have function that is, okay, this is not curry function. So your function is queued after another function, you generate D. Okay, and if you have currying, you should be able to do chaining on currying function. Okay. Okay, so this one, let's see. Let's look at the current. Let's look at the current lambda function.
Oh,
Let's try different way, okay? Current, okay, let's look at this one. So there's a function, the return function. This actually is a current function. Okay, this actually is a addition function. Okay, so let's look at this one. Actually, this one would actually do current. Okay, let's try this one. Okay, I'm going to translate to my language. Okay, may not be the same as theirs. So let me copy this addition to another one. So previous version just a function factory. It doesn't do curry. Okay. So this one, let's actually try the second one, curry one. Okay. So the second one, the function we are going to change. So this one we do have a curry function. Okay. And there's a sum function. So sum function, you put your sum function inside the current function. This one will be a new function called curry sum function. Okay, so this one it will return a function, right? And you pass the function in. So the function that you will pass in will be the sum. Okay, so let me multiply. Okay, so there I would have a function called add function. Okay, this add function will be the sum function. So here let's do add function. Just this one just return a. Okay, let me see. This one a function is a and the b, two parameter. So it would be a plus b. Okay, this one is a function. Okay, this one is the sum function that is presented here. Okay, it taking some, but let's call it add. Okay, let's call it add. Now let me look at another function called currying function. So this currying function actually would take a function f in. Okay, take a function in, and then it will return the function. Return a function. Okay, let's call this one return function g function. Okay, this g function will take a function, a parameter. Let's call it x. Okay, let's call it x. Thus, it will return a function called g, and then this function actually will return another function h. I put a name over there. Okay, and this one is y. Okay, and then this one will return the function of actually x and y. Okay, so this is the current function. So this panel whatever, that's actually deleted. Okay, let's delete that. So let's look at these two functions. The add function is a normal function that we learn. That's no problem. Okay, this one no problem. It's a function. So here, this current function, you are going to get a function. So that assuming that your curry add. Okay, so curry add. So here let's do this curry add. Okay, so adder function is actually curry in the add function. Okay, so adder function is curry the add function. Okay, so your add function is passed into here. Okay, passed into here. And actually this curry function will return the function. So this return function is g function. So this one is a g function. this G function will take a one parameter to make a new function that actually, so this one actually is either with x. So G function is either with x. So this either with x would take one parameter called y into. So this one is either always with x plus y. Y is the parameter if you take it. And you return the result for that function. Is that okay? So here, that's actually, we do have either. So we do have either 3. This either 3 is an either function with 3. Okay, so now if this function we put a parameter y for 4 here, this one we will get a variable x. Okay, and then we do panel that inner HTML class equals x equals plus x plus beyond. Okay, this one should still be 7, but we actually either is a function that will add with x, and that one take a y in, and y is 4, so you end up with 7. Okay, so this one, let's run querying. Oh, this one still no data. Okay, let me check. Okay, let me check. Go to console. Maximum code stack. Okay, query and cause minimum code. So stack size is empty, so it become recursive. Okay, let me see something wrong. Something wrong. Okay. Oh, here I should not use F. I should use H. Okay, a different name. I make a mistake. It will become recursive code. Okay, sorry. My mistake. Okay, it got A equals 7. So now this one, let's try one more. Okay. Try y equals, let's try either 1, 2, 3, 3, 4, 5. Supposed to be 15. Okay. No result. Let me check it. Okay. Yes. The either. Let's see. Okay. Let's inspect. This one is not a function. Either is not a function. Let's see. You do have over to here. Okay. I'm sorry. Okay. This one, let me see. So you do have an H function. You return the H function. So this one, you actually have, this one is a G function, and it should continue. Okay. Okay, I'm just going to check. Okay, this one, Let me try just 2 first. Okay, so 2 is okay. Let me try 3 now. Three still now okay, because the chaining failed for some reason. Okay, let me see. You curry in the add, so here you return the G function. Okay, this one still not getting the right function for it. Okay. So let me try to do different way. Okay. So let's do G function. Rewrite. Okay. So G function, we will have a G function, and then this curly function will return G. Okay. And then this G function actually will take in the X. So here I define a function called H function taking Y in. Okay, this one will return X plus Y. Okay, and G function will return a function H. Okay, let's do this. Okay, let's do this. So it actually will return a G function. Okay, so let's try this one. Okay, let's try this one. This one would return another function. Okay, let's try this way. None of them happen. So this one, H function. G is a function, you declare a function, you generate another new function. So here this Y should be the return value, should be another function, okay? So let's actually try this. Okay, so X, 2 value is still working, 3 value it doesn't, okay? 3 value doesn't, okay? This quotient I'm going to check, okay? So this is another way to write it, okay? This is 3 value still chaining, still fail, okay? Let me check. Let me check my note, okay? I may have it later. So curry 2 function, G function define H, then H, this is correct, okay? This is curry in Python, okay? This is the one that I wrote. Sorry for that, okay? I have not practiced this for a while. So this one is curry 2. It takes the f function in to operate, make either. Okay, to make either, so 2 is okay. You will have a G function, H function return. Oh, this one need to be F function. Okay, so let me check, okay. So it's going to be, this one should not be this one should be F function. Okay. Let me save and try this one. So that one I did not curry. I actually returning X, F plus X. So it's wrong, okay? Oh, sorry, still not working. So function f, let me compare, okay? Query function f, g function, and then function h. Function h return function xy, and then return h on the return h for return h is for the g function, and query function return g function. So here we actually have query adder function. Adder function is your make adder. So make adder 2, 3. You get x. That's actually okay. That's 2 variable. Okay, that's 2 variable. Let's look at 3 variable one. Let's look at some longer one. Okay. Hello, everyone. Here I'm going to talk about a chain rule. This one is a supplemental material for this lecture 8. I did not explain well in the class, so now I actually make up for it. So chain rule, okay. First, we know about the currying. Currying is to make function using partial parameters. We call it currying. And we already show you several function factory to generate functions. Here we talk about chaining rule. So chaining rule is you want to actually run the function and then get another function. So basically, chaining rule is a function factory. You can use parameter to generate a function, and that function can call another function and call another function and call another function. And we call it chain rule. Key point is that return function must be recursive. So I missed that. Okay, previous example that I gave, they are just do currying. They just providing partial result to it, but the function that we get is not recursive code. It's not the function itself. It's not recursive code. So let's look at this chaining rule for the recursive code. So let's look at it. Okay. So basically here I have an f function. So this f function, you will generate a g function. This g function, if this g function don't have parameters, say this actually you do 8 and 1, and there is no parameter, you finish. This one, you will generate a g function, and g function will add x is not defined, undefined, so you will return n, you basically return actually 1. Okay, if you do this parenthesis and then no data, this one will return a value that's 1. Okay, so if you do adder and then 1 without parentheses, then you return a function called add n plus 1. So it actually will recursively calling 1 plus x depend on x of the value that given by the flowing data here. So this x will be used for it. Okay, and that will generate a function. So basically, this one will have 2 cases. If the trading no parameter, you return the value. Or if you actually, so you may provide vector as the output. It may also provide function call as the output. And if you provide function call the output, that would be a recursive call. Okay, let's look at the next example. So you say function 1 equal 8.1. This one will return a function that actually is 8.1 to x. Okay, that's a f function. This will be 1 function if you return this way. If you put this way and then put parentheses, then the x is undefined. X is undefined, so this one actually will give you the value of 1. This one will give you the value of 3. Okay, this is the chain rule. So that's actually look at how this chain rule work in our JavaScript. So here I do have a function called chain.html. It's in the same directory that we had. So it's either n and then g x. If x is undefined, you don't do it. So here we use n. This one to generate a iter1 function. This is a function. You take x, it will be giving you x plus 1. So here iter1 plus putting the two lists is x. So you begin 1 plus 2 function and evaluate with value. So this one actually will get a value x. So this x is actually 3. And then the next one you have the iter. Iter is 8 with 1 and no value. No value, you return 1. So you get 1. And this one you get add 5, 4, 3, 2, 1. This one and evaluate it. Okay, now end up with a function. So when you do parentheses nothing, that will give you value. When you put parentheses still with some value, that will give you a recursive call function. Okay, and this one you chain up this value, and then you get 15. So this one is actually save, and then try and chain rule. Run. Okay, you get 15 on that. Okay. Thank you. Bye now. This is supplemental material for chain rule. Bye bye. The concept of currying is converting a function that takes multiple arguments into a single argument of higher order. That means that you try to create an adder. Originally, adder take 2 values, right? You add take 2 values, but you kind of trying to take this one as default value x. Okay, so your adder, it becomes an adder 3. Okay, so basically, currying is to decorate your function so that some of the value already been taken. Okay, already been taken. So basically, it return a function. It return a function that partial parameter have been taken. That's called currying. Okay, and currying function can be used to say sometimes you have a function, you have 10 parameter. But you can set some default value into there. And some of them still available. That's called function carrying. And function carrying can be used to chain function, but the chain function part I haven't worked out today. Okay, sorry for that. So that's the idea of the currying. So you have the lambda expression, the lambda expression function f, it passes a function in, and this function will be returned eventually, but you take 2 parameter x, y into there. This is also currying. So basically, currying add function. So this add function is the function you are going to return, but you will take 2 parameter x and y, and that is the value that you take. It will be getting that x and y. This one is the currying 2 argument into the function. Okay. So use the lambda expression, it works, but the chaining part, I have to figure it out, okay? Chaining part, I have to figure it out. Okay, so that actually is making a function using higher order, okay? So here, we have a decorator function, okay? Decorator function, we have a trace function. It will have trace function. So eventually, this tracer function 1 will return a trace function, and this trace function basically will print this. Okay, and then this with R value. R is the function f over x. Okay, so this is the input value versus output value will be printed in this notation. Okay, so we do trace one. Trace one is now become the decorator. So this one the same as this. Okay, so you apply the so-called square function to trace one. So now this one is actually trace one. So it's going to print x and the square of x. So you should be 3 and then getting out 9. It's actually something like this. That would be what you will get for like output. So this one is actually wrong, okay, in Python. Okay, let's do this. Let me create another one called trace1.py. Okay. Now let me copy the code directly from here. Okay, so we don't need to type. This one's decorator. Okay, decorator is it's kind of a currying mechanism in Python. You directly decorate the function. Okay, it directly decorate the function. So here's some word, some appropriate later. Okay, because I'm copying. Not a problem. Let me actually clean the symbol. Okay. Sorry for the chaining. Okay, I have to figure it out. I have not run it for a while. Okay, so this one, tracer one would generate a function called trace. Whatever function you put in, you print out the dash arrow input less than equal less than dash output. Okay, that's the purpose. So here we do finish this one, and that's wrong code. So input 3, output 9. Okay, being printed. So this one is equivalent to you actually tracer square. Okay, so this portion is the definition. And when you apply decorator tracer one, you're applying this square to the tracer. So basically, you need to use a function factory, generate function. Okay, you take the function in, provide function out. And then this function is the input to the tracer one. If you write it in this way, this one called decorator. Is that okay? So decorator is wrapping a function into another function. Is that okay so far?
Yeah, it's hard to keep track where it's going, but I'll keep studying.
It's not very naturally, okay? Okay, anyway, this is decorator. Okay, so decorator is a systematical way of doing query, okay? You know what I'm saying? Decorator is a systematical way of making higher order function, okay? It's a method that used in Python to create a query function, okay? Chain rule, I'm sorry, I need to find a chain rule for you, okay? So that it can be connecting several functions together. This portion, I'm sorry, I don't have it. I try, but fail, okay? Okay, and I'm going to find later, okay, for you. Recursive function, a function is recursive with body it call itself, okay? And this we cover it already. Okay, this one is a recursive function for sum of the digit, okay? I think this one easy, so. And you can write Fibonacci function for this one, we covered it last time already. Okay, so recursive function should be fine, okay? Mutual recursion, okay, mutual recursion. Mutual recursion is that A function calling B function, and B function may also call A function. That's called mutual recursion, okay? And this is very tricky, but sometimes you can use it. So there's a Loon algorithm to do mutual recursion. okay? And this one, you have calculated the root algorithms for sum of digit. So your sum of digit, calling sum of digit, okay? And then there's a root double. So sum, root sum, calling root sum double, calling root sum. This is called mutual recursion. You call each other, okay? And you will perform some calculation. But this one, very dangerous if you don't know how to work it out. Mutual recursion usually not going to benefit you sometimes, making things more complicated. We just listed here as an example. You can study yourself, okay? Next one, I'm going to talk about tree, okay? And I still owe you the currying, okay, Qianlu. I'm going to do that later, okay? So for next one, you need to study tree. We need to go over the tree, okay? Tree is a structure that you actually have more than one node, one subnode, okay? And it's not circular, okay? Not circular, right? But not circular. Okay, so tree you can recursive doing it every level, okay? So you have a tree, have a root label and a list of branches. Each branches is a tree, okay? And the tree with 0 branches is called a leaf, okay? And you can also use a node to describe it, okay, anyway. So tree, you have a label and branches. So it is your label and then branches, okay? And then you will find the label, find the branch, and check if the leaf, okay? So these are basic operation for a tree. So to define a tree, you can use a list to create tree, okay? So this is very simple tree structure. You take in label and tree, and then you create a label plus these of branches, okay? And you get a, so basically you can use a list, and this one's label, and then node 1, node 2, your branches, using list item, okay? Using your list element to create tree. And next level, you go down next level, another list, label, a node, and go down next level, okay? So this is a very simple structure of tree using Python, okay? So your tree can also be a constructor, label 3, and then there's a tree 1, okay, no branch. So this one construct a tree of 3, right? And then is tree of 1, and tree of 2, and tree of 2 has tree of 1, and tree of 1 here. This is the representation here. Is that okay? And the tree definition is only here. This is a very simple tree structure in Python. Is that okay? So a tree can be represented, tree node can be represented by a list, with the label and the remaining part of the branches. So when you say your label will get an element 0. Element 1 and beyond is actually their branches. Okay? Any question? Okay, so tree processing, tree is supposed to be a recursive structure, and then you can perform recursive functions such as counting leaf, how many leaf inside a tree, okay, like this. If it's a leaf, it return 1. If not, you sum up the branches, okay? And you can count the leaf sum, okay? Count the leaf sum. Okay, so copy from one tree to the other, it just recursively copy the list structure that will be duplicated. So copy. If lead node, you create a tree of the label list. If not a lead node, you create a label with the 3 branches. Then you can copy the tree from one tree to the other. It's a very simple tree copy. Okay. Any questions so far? Okay, this is tree. Okay, and print can print tree, print every node on the tree. Okay, and sum of the list. Okay, and I think this okay. So there are several type of tree. You have data tree. Okay, data tree like this. You can have component tree. So component tree say you are playing domino game, and then your tree should be subtree some part of it in the component. So data tree, component tree, expression tree. Expression tree is a tree structure for arithmetic expression. Okay, you have the decision tree, tree for you to make decision. Okay, you have recursion call tree. Okay, Fibonacci function, recursive tree. You can have game evaluation tree. Okay, these are all kind of tree, and you can use Python to construct tree structure very quickly, so you can do programming with tree. Okay, and tree passing tree in the language. Okay, this is what we will see in the second half of our course when we do compiler design. Okay, and then binary search tree. Okay, and then directory system tree. Okay, so these are different type of tree, and when tree is needed, you will need to use a push down automata. Okay, so push down automata is one important topic. When we have the push down automata, they are stack that we use, and stack is useful to process the tree. Okay, so that's push down automata. So we have to, these are the terminology in programming language. Okay, a push down automata is a way to implement counter-free grammar in a similar way we design deterministic finite automata for a regular grammar. Okay, DFA is deterministic finite automata. Okay, and deterministic finite automata have state transition. You do draw state variable, state versus state, go to another state. Okay, using input 1 or 0. Okay, to go to different state. That's called deterministic finite automata. But push down automata is the deterministic finite automata plus a stack. So plus a stack, basically, this one is just like you have a CPU plus a stack. So basically, push down automata can process most of the language conversion. Okay, that's what this one trying to say. Okay, so you have push down automata, means you have finite state machine control and operating on a stack. Okay, and it's something like this. You have CPU input and the stack. And push down automata has 3 components: input, control unit, and the stack. Okay, and it has 2 operations, push and pop. And by doing this, you can process all of the stack operations and finite state machine, and it can be used to process any program. So a formal description of push down automata is you do have multiple state, you have input symbol, you have stack symbol, you have transition for the states, you have initial state. Okay, 7 different components. Okay, anyway, that's theoretical push down automata. Okay, and it's necessary when we talk about language processing. You will need that. Okay, parsing tree, you will need that. Okay, when we do parsing tree, we will need that, but not yet. So first things you need to know about what stack. Stack is first in, first out. Okay, I'm sorry, first in, last out. Okay, and you can push and pop to stack. This one, I think it's okay. I don't redefine stack, okay? Okay, stack, push, pop, seek, these are basic operation for stack. And stack can also be implemented by list. Tree can be implemented by list. And stack can also be implemented by stack, okay? By list, okay? So this is the simple definition of the stack. You have the constructor, you have the is empty, you have push pop, okay, and your data structure is only a list, okay, and then performing the push pop over the stack, okay, and you can have a stack number 2 different version, okay, and stack you can look at the Python, okay, Python tutor to look at the state variables, different situations, okay. Parentheses. So here, let's look at the bigger view, okay? So here, this one is to evaluate the expression tree, okay? This is second half, we are going to look at the evaluation of algebraic tree, okay? So we will be using the stack to analyze the expression. That's what we are talking about here. So given a evaluation tree like let me see, expression tree. Given an expression tree like this, and we are going to evaluate, and we have homework on this, okay? We have homework on this. So basically, we are trying to analyze the parentheses, okay? And you can see if the parentheses balance. Balance means that you have a left one, you'll be paired with a right one, okay? You'll be paired with a right one. So there's a problem called balance parentheses, okay? This one is to figure out. So every time you push the one to stack, pop out with a right-hand side, okay? And if you don't have the left side and you pop out with the right side, then there is not pair. There is not pair. So we can use that to determine whether parentheses are pair or not, okay? And you can also generalize it to pair with curly brace and the bracket and the parentheses, okay? Making sure that one left side will be paired with the right side, okay? But not this, okay? Okay, anyway, this is the balance. And then algebraic expression. This one you have prefix expression, infix expression, and postfix expression. So when we do algebraic calculation, normally we are infix a plus b. But you can write in prefix version and postfix version. Postfix version turned out to be the best for expression evaluation. So we usually convert your infix or prefix to postfix for operation. Is that okay? Usually we convert this to this when you do calculator evaluation. Okay. So these are the infix and postfix and infix. Okay. And usually we like to convert it to postfix. An early calculator, say HP calculator, is using Polish expression. That's actually is this is postfix. Okay, early calculator, you type A34 plus. Okay, and this will return you value. That actually is Polish notation. Is that okay? Hello, is that okay?
Yeah, that's
And,
okay.
and nowadays the calculator become infix. but internally they are still converted to postfix for calculation. Okay, so this portion is to show you how to do conversion for the okay, and it's quite in a lot of detail, so I don't go through the conversion of each code. It take a long time to figure the whole thing out. Okay, so just knowing that the last portion we talk about is to convert different way, and you have to trace the code. Okay, we don't have that much time to go over postfix infix to postfix to infix. We don't have that, but we do have the code for you to study. Okay, so there are a lot of things, including transform of the format and also evaluation of the code. Okay, so this portion you have to study by yourself. Okay, so this chapter we are going to stop here. Okay, I still owe you the current chaining. That portion I haven't stopped. I need to find example. Okay, any question today? Okay, no question. We are up to here today. Okay, thank you. I still owe you the chain rule. Okay, sorry. See you next time.
All right. Thank you.
Thank you. Hello, everyone. Here I'm going to talk about a chain rule. This one is a supplemental material for this lecture 8. I did not explain well in the class, so now I actually make up for it. So chain rule, okay. First, we know about the currying. Currying is to make function using partial parameters. We call it currying. And we already show you several function factory to generate functions. Here we talk about chaining rule. So chaining rule is you want to actually run the function and then get another function. So basically, chaining rule is a function factory. You can use parameter to generate a function, and that function can call another function and call another function and call another function. And we call it chain rule. Key point is that return function must be recursive. So I missed that. Okay, previous example that I gave, they are just do currying. They just providing partial result to it, but the function that we get is not recursive code. It's not the function itself. It's not recursive code. So let's look at this chaining rule for the recursive code. So let's look at it. Okay. So basically here I have an f function. So this f function, you will generate a g function. This g function, if this g function don't have parameters, say this actually you do 8 and 1, and there is no parameter, you finish. This one, you will generate a g function, and g function will add x is not defined, undefined, so you will return n, you basically return actually 1. Okay, if you do this parenthesis and then no data, this one will return a value that's 1. Okay, so if you do either and then 1 without parentheses, then you return a function called add n plus 1. So it actually will recursively calling 1 plus x depend on x of the value that given by the flowing data here. So this x will be used for it. Okay, and that will generate a function. So basically, this one will have two cases. If the trading no parameter, you return the value. Or if you actually, so you may provide vector as the output. It may also provide function call as the output. And if you provide function call as the output, that would be a recursive call. Okay, let's look at the next example. So you say function 1 equal 8.1. This one will return a function that actually is 8.1 to x. Okay, that's a f function. This will be 1 function if you return this way. If you put this way and then put parentheses, then the x is undefined. x is undefined. So this one actually will give you the value of 1. This one will give you the value of 3. Okay, this is the chain rule. So that's actually look at how this chain rule work in our JavaScript. So here I do have a function called chain.html. It's in the same directory that we had. So this either n and then g x, if x is undefined, you don't do it. So here we use add n, this one to generate a iter1 function. This is a function. You take x, it will be giving you x plus 1. So here iter1 plus putting the two lists is x. So you begin 1 plus 2 function and evaluate with value. So this one actually will get a value x. So this x is actually 3. And then the next one you have the iter. Iter is 8 with 1 and no value. No value, you will return 1. So you get 1. And this one you get add 5, 4, 3 to 1. This one and evaluate it. Okay, now end up with a function. So when you do parentheses nothing, that will give you value. When you put parentheses still with some value, that will give you a recursive call function. Okay, and this one you chain up this value, and then you get 15. So this one is actually save, and then try in chain rule. Run. Okay, you get 15 on that. Okay. Thank you. Bye now. This is supplemental material for chain rule. Bye bye.